When we look at the glowing, densely packed center of the Milky Way, we assume a massive gravitational anchor is holding those stars together. For decades, we have looked to Sagittarius A star, the supermassive black hole at the heart of our galaxy, as that central pillar. But our local monster is surprisingly small. If you placed Sagittarius A star in the center of our solar system, its event horizon wouldn't even reach the outer planets. Its radius only stretches from the Sun to the asteroid belt. This lack of physical scale reflects a lack of gravitational dominance. Sagittarius A star contains a mere 0.001% of the Milky Way's total mass. The real glue keeping us from flying apart into the void is a massive halo of dark matter. Sagittarius A star defines the shallow end of the supermassive scale. To find the true kings of gravity, we have to look into the deep dark, where the proportions of space-time shift entirely. Almost every celestial body operates under strict physical regulations. If a gas giant planet accumulates too much mass, the pressure in its core ignites hydrogen atoms, and the planet collapses into a star. Stars face their own ceiling, called the Eddington limit. As a star grows, it burns fuel faster, emitting a wind of radiation so fierce that it physically blows away any surrounding gas. This process chokes off the star's growth before it can reach extreme proportions. Black holes exploit a major loophole in these laws. Because they lack a physical radiating surface, they never hit a ceiling. While the star rejects its food, the black hole smoothly pulls matter inward, never reaching a point of saturation. Without a physical boundary to trigger a collapse, the only constraint on a black hole's expansion is the amount of time it has been feeding. Over the 13.8 billion year history of the universe, some entities have had enough time to exploit this loophole to a terrifying degree. Physical dimensions do not dictate gravitational power. We have mapped stellar black holes measuring just 17.2 kilometers across, a diameter so compact that 3 of them could fit comfortably inside the city limits of New Delhi. Yet that tiny point of infinite density controls a red giant star 24 times larger than our Sun, whipping it into a rapid, inescapable orbit. To build multi-system monsters, the universe bypassed the slow growth cycle of normal stars early in its history. In the high-pressure environment of the early universe, massive gas clouds collapsed so fast they formed quasi-stars. This cross-section shows the internal mechanics of a quasi-star. Instead of a fusion engine, an Earth-sized black hole sits at the core, eating its host from the inside out. The friction of this feeding generated enough heat to push the outer gas layers away, keeping the star from collapsing until the black hole had grown into a massive seed. These ancient seeds left behind the ready-made foundations required to build the ultramassive anomalies we see today. In the distant galaxy OJ-287, we can observe the result of those seeds merging and feeding for billions of years. The primary black hole at the center of this galaxy is so large that standard astronomical units are no longer useful. You could place 3 complete solar systems side by side within its dark event horizon. Furthermore, this primary giant captured a secondary black hole, relegating a monster 40 times heavier than Sagittarius A star to a mere satellite moon. Seeing a supermassive black hole, a body that usually anchors an entire galaxy, forced into a satellite orbit, proves that the hierarchy of mass in our local universe is completely overturned at these scales. Even the scale of OJ-287 is exceeded by the undisputed heavyweight champion of the universe, TON 618. TON 618 weighs an astonishing 66 billion times the mass of our Sun. It is powered by a gas disk shining as a quasar, with the combined brightness of 100 trillion stars, completely eclipsing the light of its own host galaxy. To visualize the physical reach of TON 618's event horizon, we have to move beyond standard distance metrics and measure the object in light travel time. If you fired a beam of light from the very outer edge of the event horizon, it would take an entire week for that light to reach the central singularity. Light can cross our entire solar system in a matter of hours. Inside TON 618, that same light is trapped in a 1-week transit, inhabiting a volume that human intuition for distance cannot navigate. The sheer mass of TON 618 is compounded by a temporal reality. We are observing a ghost. Because that light spent 10 billion years traveling to our telescopes, NASA's observations capture the monster as it existed in the early universe. During those 10 billion years, the expansion of the universe has been stretching the fabric of spacetime. TON 618 is no longer the distance we observe. It is physically 18 billion light-years away from us. This creates a terrifying unknown. If TON 618 was already 66 billion times heavier than the Sun 10 billion years ago, how much larger has it grown while its old light was traveling to our eyes? The universe is far heavier than we assume. The true modern kings of gravity are out there in the deep dark, waiting for their light to reach us.